In previous lecture, we defined what is set, and in this lecture, I will show you what can we do with sets. In other words, what operations we can do with sets. First operation is called subset, and it is similar to smaller than or equal to sign, but this one is more kinda round. And A is subset of B when B contains every element that is in A. And it can also contain other elements that are not in A, and that is okay. Important is that B contains every element from A. So here are a few examples. First one is correct because 1 is in set B, 4 is in set B, and 9 is in set B. So it is true. And it doesn't matter in what order they are. Important thing is that B contains every element from A. Second example is false because in A we have 8, but in B we do not have 8. And it is not enough to have some elements, there must be every element. And also notice this, if A is not subset of B, we use this notation to describe this relation. Okay, and last example, the sets are equal, as you can see. So it is also true that B contains every element from A. In other words, A is subset of B. Now, I want you to pause the video and think about when A and B are equal and use subset operation to describe this relationship. Okay, so we know that in order for A to be the same as B, we need to have every element from A in B. But we also need to have every element from B in A, right? So now it is pretty simple to describe it using subset operation, right? A and B are equal if A is subset of B and B is subset of A. And really, if you think about it, it makes sense. For example, if A contains 4 and 6 and B contains 0, 4 and 6, A is subset of B because 4 and 6 are in B. But B is not subset of A because 0 is not in A. So A is not equal to B. Another important thing is cardinality of set, and it is just the number of elements in set. We use this notation to describe cardinality. So if we have set B containing red, blue, green and yellow, the cardinality of this set B is 4, because B contains 4 elements. Pretty simple, right? But also sets can have no elements. Think of it as empty box. These are defined by this crossed 0. And it just means empty box, empty braces, set that have no elements. And cardinality of this set is obviously 0. Also, some sets have cardinality equal to infinitive. Why? Well, they have infinite number of elements. For example, if I pick all numbers from 1 to infinity and put them into one set, this set will contain 1, 2, 3, 4, 5, 6, 6 billions, and so on, and it will never stop because we are going to infinity, and infinity just keeps getting bigger and bigger. So it's something like our universe, it expands all the time. So it is infinitive, but I will talk more about this in next lectures. Let's look at another basic operation. First one is union, and we use this operation to kind of put together two sets into one. To describe union, we use this kind of use sign. So for example, if I do union of A and B, in C will be all elements from A and all elements from B. So if A is containing 1 and 2 and B is containing 2 and 3, union of A and B will be 1, 2, 3. Why isn't it 1, 2, 2, 3? Well, we do not write repeating elements, right? I mentioned this in previous lecture. So, let's take a look at next example. In this case, A is 1 and 2, and B is also 1 and 2. So the union will be 1 and 2. You can guess the result in this case, where A contains 1, 2, 3, and B contains 4 and 5. The union of A and B will be 1, 2, 3, 4, 5. I hope that makes sense. Let's take a look at basic properties of this operation. I believe that if you really think about it, you can figure it out. So, what is the relation between A union B and B union A? Well, we have set containing all the elements from A and also all the elements from B. And then we have other set containing all the elements from B and also all the elements from A. And you don't have to be a rocket scientist to figure out these two sets are the same, right? Okay, next one might not be so obvious, but it also makes sense. A united with B union C is also the same as A union B united with C. Why? Well, if you think about it, here we unite A with the set that is containing all the elements from B and C. And here we unite set that is containing all the elements from A and B with set C. So in both examples, the final set will contain all the elements from A, B, and C, right? Okay, another interesting fact is that A union A is equal to A, right? Because this set is containing all the elements from A, kinda twice, but since we don't care about how many times element is in set, it is the same as A. And I think that is enough properties, so let's take a look at intersection. And what this basically does? Well, it takes only the elements that are in both sets. We use this kinda U upside down to describe this operation. And let me show you a few examples. If A contains 1 and 2 and B contains 2 and 3, the intersection of A and B will be set containing 2. Because 2 is the only element that is in A but also in B. So you can imagine this as if you have two boxes and you are taking only the elements that are in both boxes. Here is another example where A contains 1 and 2 and B contains 1 and 2. The intersection of A and B will result into set containing 1 and 2 because we have 1 in A but also in B. And we have 2 in A but also in B. And in last example, A contains 1, 2 and 3 and B contains 4 and 5. And the intersection of A and B is empty set because there is no element that is in A and in B. I hope this makes sense. I think it does. So let's take a look at some basic properties of this operation. First one says that intersection of A and B is the same as intersection of B and A, and this makes sense, right? Second one says that A intersected with B intersection C is the same as A intersection B intersected with C. So, if you think about it, both of these statements will result into set, and in this set will be only elements that are in A, B, and C. There are more properties, but you can figure out all of these if you really think about it. So the next property says that A intersection A is equal to A. And this one also makes sense because you grab the elements that are in both sets. And since these sets are equal, that means the result will be also equal to A. Last operation I will talk about in this lecture is complement. This operation kind of represents subtraction with sets. And what I mean by that? Well, A complement B is basically A without the elements that are in B. This might be confusing, but it is actually pretty simple. If I have here set A containing 1 and 2, and then I have here set B containing 2 and 3, the complement is described by this kinda turned divide sign, and the result is set that contains elements from A that are not in B. So you can think of it two ways. First one is that you are picking every element from A and you are looking whether this element is also in B. If it is, you throw this element away. If it is not, you add it into result. So the result of complement of A and B is set containing 1. Why? Well, 1 is not in B. So we add it to the result. Then we grab 2 and find out that 2 is in B, so we throw it away. I hope that makes sense. In next example, A contains 1 and 2 and B contains 1 and 2. So the result of complement of A and B is empty set. Why? Because every element from A is also in B. From this you can kind of figure out one property of complement. If A is subset of B, then complement of A and B is empty set. And if you think about it a little bit, it should make sense. Let's take a look at last example, where A contains 1, 2 and 3, and B contains 4 and 5. Then the complement of A and B will be A. That means set containing 1, 2 and 3. Why? Because B is not containing any elements from A. Now, let's take a look at some basic properties of complements. First one is that complement of A and B is not the same as complement of B and A. The only case where the result of these are the same is when A is equal to B. For example, try this with A containing 1, 2, 3 and 4 and B containing 1 and 2. Also, another property is that complement of A and A is empty set. This also makes sense, right? Okay, that's all there is to it. If you have any questions, don't hesitate to contact me. I'm here to help, and I will see you next time.